Hello everyone, welcome to this webinar. I'm 𝐸𝐵𝐻𝐿, your webinar host for the day. The topic of the day is big data testing. Let's have a look at the agenda. The topics that we're going to cover in this particular webinar. Big data testing is a vast topic, but then I will try to give you an overview of what kind of testing, what strategies, what are the different types of big data, and what are the different problems and tools that we have in this particular world. So why do we need big data testing will be the question with which we will begin the webinar. And what is big data testing for that matter? Strategies behind big data testing, big data forms, what are the different forms big data takes? That means, different types of big data. Then we talk a little bit of big data testing environments, big data testing tools which are available here. There are different aspects of big data processing. Each tool caters to that particular aspect. So we will be looking at these different testing tools. Of course, we are talking about big data, so it's not going to be simple testing such kind of a data. So what are the different challenges that we might face in testing the big data? And then, of course, at the end of it, we will do a small comparison between the big data testing methods and tools and the traditional testing, normal testing that we have. Just like your traditional testing, here also we have the unit testing, functional testing, non-functional testing. We are going to have a look at all of those aspects of the big data testing. Okay, so let's move on with this. Why do we need big data testing? That is the question of the day. So I'll give you, I will explain the importance of the big data testing with a very popular and an example which is very close to our heart, because all of us definitely do a lot of banking, and banking is the industry which is the biggest user of big data and big data technologies, right? So the never-ending search for creation, storage, retrieval, and analysis of the colossal volumes of data triggered the motivation behind the origin of big data. Okay, so even though I'm giving an example of banking here, but then there are many other sectors like manufacturing, you name a sector, the pharma sectors, and all of those sectors, they are using big data in a very big way. Now, what is big data? From the name itself, you might have guessed the data which is not normal data. And just the size of the data doesn't really make it a big data, but then various other aspects, the complexity, the velocity, the volume, the varieties of the data, the kind of veracities we can have, the kind of noise in the data, impurities in the data, all of that data, all of those different properties which make the data processing and storage difficult, using the traditional RDBMS systems that we were very used to, very familiar with, they are just not capable of even storing and processing this data. As those systems fail, our traditional testing systems also fail, right? Whether it's a normal data or a big data, when we are storing and processing this, we definitely require to test it, right? The testing such a gigantic amount of data requires precision tools, remarkable frameworks, and brilliant strategies. We are going to talk about all of these tools, strategies, technologies, techniques in this chapter, in this webinar today. So as I said, why do we need big data testing? Most of the users might end up with one question, and this is a very important question. Why do we need big data testing? The answer is, I will try to explain this answer with this example of bank. Now, banks, as I said, banks are the biggest users of big data. They have various branches, various departments, various customers, various transactions of that customer. All of that is being stored in the storage systems of banks, right? And this is huge data. So, I will explain this necessity in this banking environment by giving you an example. Let us assume a classic case of, some kind of a processing. We have a record of a customer. The designer of the bank database named the customer bank location pin code as CL. Okay, the customer bank location is CL at the column name. The customer ID column is CI, and there's a column called customer phone number. Okay, now bank wants to make the key value pairs of customer ID, that is CI, and customer phone number, that is CP. In this scenario, the MapReduce algorithm gets messed up between the P and the L. Okay, so right in the beginning, these two fields are wrongly processed and wrongly stored, then the CP, that is the customer phone number, is replaced with the key value pair, that is CL, that is customer location pin ID, and the customer ID. We do not have the CP participating in this key value pair, which is processed by the MapReduce code, right? MapReduce is one of the frameworks that we use to process big data. Now, because this phone number is missing, a very small maybe negligible error, but then all the further processings will have that error carried over in that. And then when the customer actually does some transaction and the time comes to receive an OTP, because the key value pairs doesn't have the customer phone number included in that, the customer is prohibited from doing a phone banking, from using a phone banking facility, right? Now, just imagine this real-time situation. To avoid such mistakes, we prefer to test the big data. Now, this error is very small, correct? And in front of this colossal amount of data, it is really difficult to, so it is very difficult if we do not track these errors, these small minuscule errors in such a huge amount of data right in the early stages. And this identification of such minuscule errors, the big data testing processes and tools and technique allow us to do that, and we can avoid a very big disaster maybe in the future. Okay, so after understanding how important the big data testing is, now let us understand what is big data testing. Okay, so big data testing is a collection. Big data, first of all, let's try and understand big data. The big data is a collection of huge amount of data that traditional storage systems cannot handle, right? The data is in various formats. The traditional systems just cannot stand in front of those formats. Forget about processing it. Even storage is a problem with traditional RDBMS systems. The big data testing can be defined as a procedure that involves examining and validating the functionality of the big data application, right? Application means the processing mechanisms that we have implemented and the data on which these processing mechanisms are implemented, right? As the data is huge, we are using big data technologies. So obviously we cannot use our traditional testing techniques on those. So that those are also going to be different. Those also need to be evolved. Testing such a huge amount of data would take some special tools and techniques and terminologies. So let's have a look at what those are. Strategies behind big data testing. This is a very important aspect here. So the testing an application that handles terabytes of data would take the skill from a whole new level and out of the box thinking. As I said, the traditional testing mechanisms that we are very used to is definitely not a match in front of this big data. So what are the different strategies? Okay, the core and important tests that the quality assurance team concentrates, it's based on 3 scenarios. Okay, for the testing strategies to work, we have 3 different scenarios when it comes to big data. Now, what are those 3 scenarios that we have? We have batch processing of big data. We have a real-time processing of the big data. Sorry, the screens. And then we have the interactive processing of the big data. Now let's try and understand, first of all, before we move on to the big data forms, let's try and understand what are these different scenarios. Okay, so batch processing test is the test involves test procedures that run the data when the application is in batch processing mode. Okay, when we talk about the MapReduce processing. Batch processing means you collect a day's data and then maybe you process it through through MapReduce programs overnight, and then the next morning the output of the crunching of this data is ready. So the data processing happens in batch. So data, when the application is in the batch processing mode, the application is processed using batch processing storage units, like we have HDFS and all of these things. Now you might have in a bank setup, you would have Oracle systems, right? So, or in Oracle OLTP systems, you will collect a day's data, the transactions of the customers, and then you will dump them at the end of the day in your maybe HDFS based data lake, and then apply certain MapReduce applications which will be running on this data overnight in the off-peak hours of the bank. And then next day, the managers and different stakeholders, the data will be available to them in the form of different reports, which is a result of this MapReduce processing. Okay, so the batch process testing mainly involves running the application against faulty inputs and varying the volume of the data. The volume is a very important aspect of big data. So when we are testing this, we are running the application against various faulty inputs. So stress test or something like that, you can call it. And also, we will try to test our system processing systems, batch processing systems, with various amounts of data. How does it function under various types of various amounts of loads of the data? Then the next scenario that we have seen is real-time processing test. Okay, now when the application is in real-time data processing mode, many times what happens is we need to do the credit card for fraud detection, those kind of use cases, if you imagine. And if you allow the credit card transaction, fraudulent credit card transaction to go through, and then maybe you record the details, you dump it to your Hadoop systems, and then process it through MapReduce program overnight, and the next morning the report tells you that this transaction was fraudulent, right? So batch processing is definitely not going to help you. For these kind of use cases, we use real-time processing of data. Now, what are the different tools that I use for real-time processing of big data? Spark, Storm, these kind of tools are available. The application is so you need to have different strategy to test these real-time processing engines like Spark and Storm. Real-time testing involves the application to be tested in real-time environment, and it is checked for its stability. When the inflow of data increases, what is the response of this real-time processing engine? How stable they are, first of all, and what is throughput? What is the accuracy of the results produced? Right. So all of those things will be tested in this particular scenario. And the third scenario that we checked was interactive data processing test. Right. Now, interactive is this integrates the real life test protocols that interact with the application as in view of the real life user. So you will not put the test, you will not put the processing on a batch of data, or you will not put it in automated fashion as in when the data comes in, it gets processed. That is real time. But you have a data stored, let's say in HDFS, and you want a customer or maybe a bank executive to fire certain queries on that data, and then in an interactive manner process that data, right? So that is your interactive processing. And then all the techniques that we use to test this kind of processing is your interactive data processing test. So that involves your tools like 𝐹SQL and those kind of things. So you actually want to again test the accuracy of the results produced by these kind of queries. Okay, let's talk about the different big data forms that we have. What are the different big data forms? First of all, we have understood what is big data, but then big data also has different categories of it. The very first one is structured big data. The second one is semi-structured big data. And the third one is unstructured big data. Any type of big data you talk about, you will always see that big data fitting in one of these three forms. Okay. Now let's go a little deeper and try to understand what these forms are. So the structured data, as the name suggests, any tabular data which is meaningfully organized under rows and columns with easy accessibility is known as a structured data. Pretty much the way we have the RDBMS tables, in which you have data stored in the form of tables, rows, and columns. So we have a definite structure to that, right? So we know a banking customer has a name, has an ID, has an account ID, then the transaction date. So these are the columns. This is a very structured data which is coming in. Right? It can be organized under named columns in different storage units such as RDBMS, Oracle, MySQL, and those kind of databases are basically made for this kind of a data. Today also we have structured data, but then it is a minuscule amount of data that we have. The example of this kind of data is tabular data, which can be stored using RDBMS system. Now, the second type of data that you see on the screen is semi-structured data. The data lies perfectly between the structured and unstructured data. We will talk about an unstructured data a little bit later. So it cannot be directly ingested into RDBMS systems. Now, let's say we have some file, let's say CSV file or an XML file or a JSON file. Those of you who know these file formats, they know that the data is not in the form of columns, rows and columns here, right? We cannot load the RDBMS tables directly from these kind of files. We are calling it as a semi-structured because the tabs, the tags, the XML tags, the JSON tags are fixed. Now you need to extract data from these tags, cleanse it a little bit, and then convert it into a format which gets to a row and column format, right? So it has a kind of a structure which later on after some processing can be converted to structured data. This kind of a data is called your semi-structured data. Some kind of cleansing is required on that data. Now, all your .csv files, .json files, .xml files, and different, there are many other different file formats which have a data in semi-structured data. Majority of the data today is also in this format. So this is the number 2. The amount of data which is in this format is at number 2 nowadays. But then the biggest challenge is the third type of data, third category, third form of the data that we see on the screen, and that is unstructured data. As the name suggests, we do not have any semi-structure on it. We do not definitely have any columns and row structure on this data. The data that does not obey any kind of structure is known as unstructured data, right? The unstructured data is difficult to store and retrieve. Now, some of you might say we have blob and bfile and those kind of things in RDBMS, but that is a different mechanism, right? You store a pointer to that data and it is stored as some file somewhere else. It is not actually stored in the RDBMS and definitely cannot be processed as your normal structured data, right? So this is this is the biggest amount of data that we have, and the kind of images, videos, audios that we interact very fondly on your e-commerce side, on your social networking sites. So the maximum amount of data is nowadays getting generated here, the big data that we talk about, and it is mostly in the form of audios, videos, images, and we need to process those also. So that is also a valid big data which needs to be stored first and then processed to derive various patterns out of it and to make decisions out of it. Facebook, Yahoo, and other social networking giants and e-commerce giants are actually building their business on top of their analysis of this kind of a big data. Correct? So these are the various forms of data. And if you put these data, these types of data in the form of a pyramid, then you will see that the unstructured data basically forms the base of the pyramid, and the structured data forms the apex of the pyramid. So very small data nowadays is structured, and most of the data that we see today is unstructured data. Okay. Accordingly, the storage and processing mechanisms have changed, and as I'm reiterating again and again, our processing systems have also, the testing systems and scenarios have also changed. I've given a small listing, a briefing of all of those different forms that we have discussed so far. Structured is your data warehouse, data, databases, ERP, CRM, all RDBMS based systems. Semi-structured is your CSV, XML, JSON files. These are semi-structured, and your audio, video, and image files are nothing but your unstructured data. Okay. So because of this, we have various testing environments developing. So let's have a look at the testing environment. The basic requirement that make up data testing are space for storing, processing, and validating terabytes of data should be available. Now we are talking about big data. Forget about processing that data, testing the storage and processing of this data. First of all, The biggest challenge that we need to cater to, where to store and how to store this data in its entirety, right? If we kind of archive 90% of the data and only the 10% of the data is live, that is not called big data processing. Big data processing means everything that we have as a complete data is available. So we need to have a space for storing, processing, and validating terabytes of data. They mentioned terabytes, but then this is definitely petabytes and zettabytes of data also. The cluster and its respective node should be responsible. Now, mostly all of these big data solutions, you will find that they work on the principle of divide and conquer. That means break this data into pieces and then store it. Now, how do you store these pieces? You have collection, you have cluster of various nodes. You call it as distributed and parallel storage and processing systems. Most of the big data solutions are these clusters of various nodes, right? Now, if you want this entire system to be tested, then definitely all of these nodes which are there, now there might be hundreds and thousands of nodes in such cluster. You need to have these respective nodes responsive. Each one of them should be responsive in order to get tested. Data processing requires a powerful CPU that should be available on each one of these nodes. So these are some environmental requirements. These are the requirements of your big data testing environment that you need to have in place. This is definitely not the question for, the challenge for your traditional testing. But when we are talking about big data, definitely you need to have a robust environment catering to these three characteristics. Okay, so now let's talk about the big data testing. Okay, we have talked about the necessity of it, what exactly it is, and all of those things. Now let's get our hands dirty with the big data testing. The general approach to big data testing application involves three stages. Okay, data ingestion, data processing, and validation of the output. Okay, so let's have a look at each one of these stages now. As I said, the very first stage is your data ingestion stage. Right? What is the very first stage here? The data ingestion. What do you mean by the word ingestion? Getting data into your big data systems. Data is first loaded from source to big data system using extracting tools. So it can be your ETL tools such as your Informatica, but then there are specifically big data related tools such as Talend and Kafka and those kind of things. The storage might be HDFS or MongoDB or any other big data storage solution. Then the loaded data is cross-checked for errors and missing values. If you ask any data scientist or a machine learning scientist, they will tell you that the maximum time of their work is spent on cleansing the data, getting the anomalies in the data, the variances in the data out of the data. You call it as data cleansing, data wrangling. So your data ingestion needs to take care of that. Okay, so the very first stage is data ingestion. In this, you might have various tools like Talend, Informatica, Kafka, those kind of big data related tools. The next is, once the data is ingested in your system, the next stage is data processing. In this stage, the key value pairs of the data get generated. Later, the MapReduce logic is applied to all the nodes and checked if the algorithm works fine or not. Now, algorithm is a distributed and parallel processing framework on top of Hadoop that allows you to process the big data. So here, the data processing phase, after the data is in, we need to develop these MapReduce codes. And as this MapReduce code, different parts of the MapReduce code are going to be executed on different nodes. So we have to integratedly test these different nodes which are running your MapReduce code snippets. The data validation process takes place here to make sure the output is generated as expected. So data gets in, it gets processed, and we get certain output created. So the next is going to be the data validation, the output validation from our big data processing. At this stage, the output generated is ready to migrate to the data warehouse or to your OLTP systems also through tools like Scoop and those kind of things. Here the transformation logic is checked, the data integrity is verified, and the key value pairs at the location are validated for accuracy. Right? So these are the three different important stages of big data processing that we need to have tested. At each stage, we will have different types of testing, different strategies of testing, and different tools of testing. We will see later on the different tools at each of these levels. Okay, so now, I mean, those of you who are familiar with testing must have heard of these terms like unit testing and those kind of things. In big data processing also, we have these kind of types of testings. So let me first tell you the different types of testings that we have available here. So there are many categories involved in which a big data application can be tested. So few of them are unit testing. Then we have functional testing, non-functional testing, performance testing, and architecture testing. Let's have a look at each one of these one by one. First is your unit testing. As the name suggests, we are testing small units of your processing or your storage mechanism. The complete big data application is divided into segments, and each segment is rigorously tested. Now, when you say big data application, it is actually a solution which involves maybe your ingestion, your processing, your output validation. It might be your data ingestion tools like Kafka. It might be your batch processing systems such as Hadoop and MapReduce. You might be processing real-time data using Spark, and then you might be getting the result to back to your RDBMS system using Scoop. So it will be a collection of many such tools, right? So in order to test your big data application, you will need to divide your entire application into segments. Those might be homogeneous segments, heterogeneous segments, means same types of applications, and then tested rigorously, sorry, with multiple possibilities for an extended outcome. Each system is a unit in its own. It might have a different set of inputs and outputs. We need to be able to test all of those things. If the segment fails, then it is sent back to the developments and improvements, right? If your Kafka pipeline, if you have set and that is failing, maybe breaking under the certain volume of the data, or maybe the throughput is less, some fault tolerance is not there, then while you're testing your Kafka unit, your ETL unit, you might send it back to your improvements and development teams who are working on Kafka, right? So that kind of separate segment testing is your unit testing. Next, in the next type of testing for the big data is your functional testing. In functional testing comprises of the different phases in testing the big data application. The big data application is designed to deal with huge blocks of data, correct? So in functional testing, we have data validation phase, we have data integrity phase, then we have data ingestion phase, data processing phase, data storage phase, report generation phase. These are the different phases that we have. Now let me just take you through what each one of this phase means briefly, and then we will go to the next type of testing. Now, data validation phase deals with the business logic and the layers in the big data application. So in your entire application, wherever you have written your business logic, you might have a business logic it's written in your MapReduce code, in your Hive queries, in your big jobs. So you need to test, the functional aspect of your logic. You might have to integrate all of these different components and test the functionality. The data is collected from the source and it is run against the business use case, correct? Now the data collected is checked for accuracy and movement through the layers of application. At this stage, the big data is tested with aggregation and filtering mechanism. You might have different filters and all of those things. The data undergoes end-to-end validation and transformation logics based on business rules, correct? Now, what are these different things here? Data validation phase has these different things being tested. Now, the next is your data integration phase. Let's see what gets tested in that. Data is checked for completeness with referential integrity validation, right? How integrated the data is. Data constraints, duplication is verified against error conditions. Boundary testings, which recognize schema limits for each layer. Are there any outliers? What is the data maximum minimum limits and those kind of things. The next we have data ingestion phase testing. The ability of the application to connect with different data modules is checked. The data is replayed with messaging systems and any loss of data is monitored. Now, what are the messaging systems we have in your big data application? Kafka, Talent, right? Under various conditions, failure conditions, how these systems perform. Is my data getting to my destination from the sources through these ingestion methods that I'm using? That is tested in the data ingestion phase. The main motto of this phase is to achieve fault tolerance, continuous data availability, stable connection with a variety of data streams. Correct? How robust these messaging systems are, which are getting data from the source systems to the destination systems. Then we have the data processing phase. Once the data is ingested, we are testing the data processing phase. The data processing phase carefully examines and executes the business logic. The business rules are cross-validated. The MapReduce logic is validated at every stage. Now, MapReduce has different sets of stages: mapper stage, reducer stage, combiner stage. So at every stage, the output of each stage is validated. Data is processed from end to end. The application is checks for exceptions and they get perfectly handled. Whether they are getting perfectly handled or not, all of that will be checked in your data processing phase testing. Then we have the data storage phase. Now, we should have taken it a little bit earlier after ingestion, the storage. But then never mind. I mean, we can go in any stage. The importance is what gets tested in what stage. The data storage phase concentrates on the read and write timeouts, continuous availability of the data which is there in the system, load balancing. If there are multiple nodes in your system, we need to test here, is the data distributed evenly on all the nodes? Because if one of the node is skewed, if the data distribution is skewed, then the processing will also be skewed. Some of the nodes will sit idle while others will be overloaded. We want to check all of that thing. Query performance analysis. Obviously, if the load is balanced, then the query performances which are running on the system is going to be optimal. So we need to test all of that in your data storage phase. And then finally, we have the report generation phase. It is the final stage in functional testing, and it deals mainly with data validation for measures and dimensions, real-time reporting, data drill up and drill down mechanism. Those of you who have worked with Essbase and those kind of Cube kind of applications, you will understand these. And then business reports and charts. Now, what is the end result of all of this big data processing? You get the data ingested, stored, processed, and finally you want to tell a story to the business, right? In the forms of reports and charts and those kind of things. So how is my data faring on that front? So the report generation stage, the final stage that we need to check in your big data application. Okay, now once that is done, then we have the next phase. These are all the stages in the functional testing though. And then we have the non-functional testing. Non-functional testing phase takes care of the three major dimensions and characteristics of big data. That is volume, velocity, and finally the variety of big data, right? So now these are the different aspects of this which get tested in the non-functional testing of your big data. So let's have a look at that. The first one is data quality monitoring, infrastructure, data security, data performance, failover test mechanism, as you can see on the screen. Let's have a brief look at each one of these. So data quality monitoring checks for erroneous data records and messages. Okay, is the data which is landed here or getting out as an output, does it have erroneous data in it or not? The data quality monitoring makes sure that the data accuracy, data precision, data timelines, data consistency, and data profiling is in place in your big data application. Then the next aspect which is getting tested in the non-functional testing is infrastructure. The infrastructure makes sure there is a continuous service availability in internal big data application systems and external big data application systems. What is internal big data applications? Something which you have in Hadoop. You might have Pig, Hive, and all of that. Those are Hadoop ecosystem components. Data is getting into the Hadoop cluster through Kafka or maybe Talent. Those are external applications. So are they working in tandem or not with each other? That you test here in the infrastructure testing. Infrastructure also takes care of data replication, data backup, data restore. What is the mechanism of fault tolerance for data in your system, in data application? How is it getting backed up? If required, how is it getting restored? All of that is getting tested. Then we have data security. Now, data security, I don't have to emphasize much on this, but this is definitely one of the most important aspects. Whether the data is in motion or at rest, it needs to be secured. So you have various authorization, authentication tools like Kerberos, Ranger, Sentry, those kind of tools. Are they working as expected or not? So data security is most important aspect. Data security stage protects the sensitive data. It manages user authentication checks and user role-based authorizations, as I said, Kerberos and Sentry, Ranger, those kind of tools. Data encryption and masking of personal information, if required, is that happening or not in your bigger data application? All of that will be checked in your data security non-functional testing. Then we have the data performance. Data performance evaluates every single component, evaluates maximum data processing speed, data capacity size, maximum data capacity size, checks the message transfer speed and response time from your application, calculates the number of operations performed per unit time, the throughput of your big data application, engages parallel jobs monitoring. Now, most of these big data solutions are distributed and parallel processing system. Each of the node in this cluster is doing some kind of processing in a parallel fashion. So you need to focus on each node's parallel, how are they contributing to the parallel processing of the data. So you might have to do the parallel job monitoring also. Performs read, write, and update operations on real-time databases. How is it happening through your big data solutions? So you get the data in your Hadoop system, you process it using MapReduce, and then you again, the processed cream data, you again load back to your Oracle systems, right? So those kind of external system, how is the import-export happening? Is the data accurately going to the destination systems or not? All of that will be checked in the data performance. And then finally, we have failover test mechanism. Ensure seamless data processing while switching to neighboring data nodes. These nodes are talking to each other. The data get transferred from one node to another node. If the node is processing good, and when the time to share it with the other node, if that node is down, you might skip some part of the data, right? Which might consolidate in the final result. So that kind of failover test mechanism is required. Create data recovery points parallel and be ready for calamities. Be ready to replay the data using multiple offsets, enable dynamic clustering. All of those things will be tested in your failover test mechanism. Now, after the non-functional testing, then we have the performance testing. Performance testing highly concentrates on the performance delivery by all the components of the big data system. Right? In unit testing, we have tested the components separately, but now in this particular phase, we test the performance, the throughput of all of these small units of your big data solution working together. Okay, so now there are also different phases here in the performance testing. So let's have a look at them one by one. Okay, so the performance testing includes the data collection phase, data ingestion phase, data processing phase, component peripheral testing phase, right? So what is data collection phase? In this stage, big data system is validated based on its speed and capacity to ingest data within a given time frame from the different sources like RDBMS, database, data warehouses, and many more. So you might have certain SLAs on your ETL jobs, which are getting your data from various heterogeneous or homogeneous systems into your big data solution, right? So data collecting phase testing will be done. The performance of those systems will be tested here. Data ingestion phase. The next phase after data collection is data ingestion. Here the application is tested and validated based on its pace and capacity to load the collected data from the source to the destination. Destination can be HDFS, MongoDB, Cassandra, and the mechanism can be Kafka, right? So how it is performing. So we're talking about now Kafka's performance. Then we have data processing. Once the data is ingested, so if you look at these stages, these are the stages which are very common in different types of testing types that we are seeing here, right? The ingestion, the processing, the output. Here the application is tested based on the MapReduce logic written. The logic is run against every single node in the cluster and processing speeds are validated, right? How fast, how performant are your MapReduce jobs? The queries to be executed are expected to perform high speed with low latency. Okay, now it will depend on whether it's a batch processing or real-time processing. Based on that, you will have different parameters for this type of processing. Then we have component peripheral testing. This stage is related to component performance. Each component in the system should be highly available and connected. As I mentioned earlier, big data solutions, big data applications are mostly distributed in parallel systems. Many nodes are there in the cluster. Any failure in the connections and the networks between these nodes will result in the failure of the system. So component peripheral testing needs to be done, which is done in the performance testing. Okay. The component backup should be online when nodes faces failure. There should be a fallback node or something like that available in your cluster. High capacity data exchange should smoothly be supported in case any node fails. In Hadoop, we have something called replication factor, right? So when the data is distributed across various nodes in your Hadoop cluster, there are replicas also which are lying in different nodes of your Hadoop cluster. So main copy of the block, if it fails, then is it picking it up from the replica or not? Is the replication done properly or not? So all of that is done in your performance testing. Now, when we talk about performance testing, there are performance testing. Let's have a look at what kind of approach do we follow in the performance testing here. So as you can see, the procedure begins by establishing the big data cluster and running the application, right? Let's say we have a MapReduce application. You have your cluster initiated. Now MapReduce job is started. Design the workload required to run the test. Design the workload required to run the test. Involve the client in the test. And take their feedback. At every stage, the input output should be tested and the feedback should be taken. Execute the application with the data and analyze the result. If the application is performing with optimum stability, then process is finished. The application is successful in doing what it is supposed to do. Otherwise, apply the required modifications suggested by the client or by the tester and retest the application and follow the entire cycle of steps here. Okay, so that is basically the performance testing approach that we follow. And in this performance testing, we are testing all of the different phases that we saw earlier: the data collection, the data ingestion, processing, and component peripheral testing. Okay, so for parameters for performance testing, what are the different parameters that we should be focusing on while we are doing the performance testing? So let's have a look at that. The very first one, as you can see on the screen, is data storage. Take note of the orientation in which the data gets. Okay, the first one is data storage, in which the data gets stored in the system. Then commit logs mark the limit of committing logs. Many systems, especially in Hadoop, when you change your data across the nodes, there is a name node which needs to have this edit log, commit logs accounted for, and then to build the metadata in its memory. So commit logs. Concurrency, check the number of threads allocated for read-write processes. It might also depend on the CPUs available on each of the node, vCores that are available for these processing on each of the node. So we might test these parameters also when you're doing the performance testing. Caching, dedicate the row cache and key cache. Now this generally happens when you're doing the Spark processing, real-time processing. Okay, timeout, set timeouts for applications, connections, and queries, etc. So how many times the system gets timeout? What should be the duration of the timeouts for any processing which is maybe going slow or delayed? All of those things need to be tested. These parameters need to be tested in your performance testing phase. And then finally, we have the architecture testing. Architecture testing concentrates on establishing a stable Hadoop architecture. The architecture of big data processing application plays a key role in achieving smooth operations. Now, whatever processing, the storage, the cleansing, the output, and the parallel processing testing and performance testing and everything, all of that is happening on your big data solution. It can be, most of the times it is Hadoop, but then it can be MongoDB and other things also. But then let's assume it is Hadoop. Then the architecture testing concentrates on establishing the stable Hadoop architecture, correct? The base, the foundation of all of this, on which all of this is happening, is your basic Hadoop architecture. Whether your nodes, your master nodes, your slave nodes are performing the way they are supposed to do. Is the communication, is the network stable across the different nodes which are there in your Hadoop cluster, right? All of these things are covered under your architecture testing. Okay, so in architecture testing, so in your architecture testing, you have again various aspects, that is performance degradation. Just a moment, guys. Performance degradation, node failure, high data latency, high maintenance. If those are the problems you're facing at your big data solution architecture level, let's say Hadoop architecture level, then you definitely have to fix that first. Unless and until you have the foundation and these aspects of your architecture fixed, rest of the things will not go function as expected, right? You will have various problems in various stages of your performance. But so even though we are taking this architecture testing at the end, that is the basis of everything. Okay. Okay. So now let's talk about the various big data testing tools that we have available. Now, earlier we have seen throughout this session that there are four main stages: the data ingestion, processing, data storage, and data migration, that is output of the data. So there are different tools which we can use to test the different phases of your big data application. So these are the different application, these are the different phases. The very first one is data ingestion. In this category, we have Apache Zookeeper, Kafka, Scoop, Flume, NiFi, these kind of technologies we can use to check the data ingestion part of your big data application. Then we have data processing. In data processing, we can use MapReduce or Hive or Apache Pig. These kind of tools can be used for doing that kind of testing. Then we have data storage. The data storage can be Amazon S3 or it can be HDFS. Nowadays, it's an era of cloud. So many big data solutions are becoming cloud native. And in that case, the data might be stored on your S3 storage, or it can be HDFS on in-premise. So those the testing of your storage would be the testing of these aspects, actually, these tools. And then finally, we have the data migration or output, final output. Okay. So for that, we will have Talend. Again, Scoop will also in the data migration thing. Talend is a ETL tool which is built for big data solutions. Okay. Then CloverDX. These are some of the tools that we can use to test these aspects of your big data application. Now, having said that, given the nature of big data, the complexities of big data, and the different parts that we have to test, there are key challenges faced by the testing during the testing. So big data testing is highly complicated because it is not a testing of one system or one application. There might be plethora of applications, and that too working on a cluster of nodes, hardwares. So it gets complicated. Automated big data testing procedures are and not suited for unexpected errors. Okay, so you need to have your test strategies well defined. Virtual machine latency creates latency in test, and managing multimedia is a hassle. Now, big data is mostly your different formats that we've seen earlier. That becomes or problematic, a little bit problematic. The volume of data is one major challenge for testing. Forget about testing, having a proper testing tool and strategy in place. First, placing that data, storing that data, and then being able to apply these test strategies on them is a huge problem while you do big data testing. Test environment and automation should be developed for different platforms. As I said, in big data application, you have different platforms, different applications working together to bring about that one big data application. So you need to have different strategies, automations, and environments for each one of those platforms. No single tool can perform end-to-end testing. Same reason, because you have different types of tools, different types of applications being part of your big data application. There might be different tools for testing use. As we saw in the previous slide, for different types of tools, there will be different strategies. High degree of scripting is required for designing test cases. Depending on what kind of application it is, you might have to write some elaborate big scripts, Hive scripts, shell scripts, 𝐂𝐳 scripts, depending on the tool that you're using. So those are some of the challenges faced here. Let's see what are the differences. Let's summarize, a couple of points here in big data testing and traditional testing. The very first important point here is big data testing supports all types of data testing. That means different types of data that is called as big data: audio, video, text, structured, unstructured, semi-structured. Traditional testing supports only structured data testing. Next is big data testing requires research and development. As it is complicated, you need to have a good knowledge of the applications, the softwares being used in your big data application. Traditional data testing doesn't need research and development because it is one monolithic system that you're testing, and it might not require that complex research and development. Data size is unlimited in data testing, in big data testing. It is a big data, right? So it is going to be unlimited testing, data testing. Data size is limited in traditional testing, which makes it a pretty simple one. Then big data testing requires special environments. We have seen the environment as in testing environment, constraints, considerations that we need to pay attention to. Traditional data testing doesn't require special environment. They have some tools which we can use out of the box for testing that particular system in a traditional system. Whereas in the big data, depending on what kind of application are used there, you will have different testing environments. Then we have only the highly skilled and qualified candidates are preferred for testing. Basic operations knowledge is enough to run the test, because of the nature and the difficulty levels that we have in your testing for big data. We have some specialized roles dedicated to that we need to use in your big data testing. Okay, so guys, that brings us to the end of this particular webinar. Thank you so much everyone for listening in and being so patient.